Okay, so the next topic that I want to talk about is truth tables. So let me just put some lines on here. So before I do a problem on truth tables, let's just go over the rules of logic. Okay, so there's I guess there's technically like 4 rules, right? So the symbol that looks like this, it's referred to as a not. That changes the truth value. So if you have a statement and I tell you it's true and then you throw a not in front of it, well, now that statement is false. And vice versa. If a statement is false and you throw a not in front of it, then it becomes true. The next symbol we learn is and. So and is a really strict statement. Like think of like instructions that you would give your students. Like if I said, if you want to pass this class, you've got to have good test grades and good homework grades. Like that's really restrictive. That means that you can't get away with just one of them. Like you have to have both of them. So and if you connect 2 true statements with and, it will equal true. But any other setup is going to be false. So if there's one false in there, then the whole thing is false. So and is like really restrictive, or is a little less restrictive, right? Like, again, think of something you would tell your students, like, well, you can do your homework or you can take the tests. Like, okay, they could do both, but as long as they do like at least one of them, they've satisfied your requirement. So or is a little less restrictive. Like you can be true, you can have a true compound statement as long as one of the component statements are true. So the way I remember or is that the only way it's going to be false is if they're both false. So the way I remember or is false or false equals false. And then the last symbol that we get is this arrow symbol, and it's a conditional. It's called if then. You could also call it implies, right? P implies Q. I find myself reading it as implies, but the idea is if then. And if then is kind of tricky, right? It's not just like, oh, you have to have 2 of these or you have to have 2 of that. Like an if then statement is pretty strong because it implies like a consequence. So again, I always kind of think about my students or my children with an if then statement. Like I'll use something with my kids because, you know, we're focusing on like littler kids here for elementary education. So if you clean your room, then I'll give you candy. Right? So this is kind of a loaded statement, right? Like those kids have something that they have to do first in order to get the candy. So let's say, right? So we'll just say cleaning implies candy. So let's say it's true. They did clean their room and you followed through. You gave them candy. So you clean your room is true. I give you candy is true. So true implies true is going to equal true. Well, let's say they didn't clean their room, right? So you say, hey, you got to clean your room, and they don't do it. So they clean their room is false. But you know what? You're kind of a pushover, and you just give them the candy anyway. Well, you're not a jerk, right? Like you're kind. You've given them candy even though they did not follow through with their portion. You're still a nice guy. So that's also a true statement. And then, you know, in contrast to that, let's say that they did not clean their room and you did not give them candy. You held your boundary. You're like, hey, you didn't follow through, so I'm not following through. right? You're also fine. You're doing a good job. So this is a true statement. But you'll notice that there's like a little blank in here. What if they did clean their room, right? Like you're like, hey guys, you have to clean your room. And if you clean it, then I give you candy. And those kids were like, yeah, let's do this. I'm gonna clean my room. And then you, for whatever reason, do not follow through. You do not follow through. You do not give them candy. Well, you're mean. Like, that's just not nice. It's a broken promise. You promised them that if they cleaned their room, you would give them candy. They cleaned their room and you didn't follow through. That makes a false statement. Like, you were lying from the get-go. So you'll notice again in this setup that there's only one that stands out. Everything is true unless the antecedent is true and the consequent is false. Then the whole statement is considered a false statement. So the way I would remember the if-then or the implies is that true implies false equals false, and everything else is true. So these are like the 4 most basic symbols that you'll see most of the time. So now, how does that relate to truth tables? Well, when you're doing a truth table, you're analyzing every possible setup for your component statements. So in case one, your P statement is true, your Q statement is true. And then you analyze what happens at the end of the day with that. In case 2, your P statement is true and your Q statement is false. And then you analyze what happens with that. Case 3, your P statement is true and your Q statement is false. And then you analyze that case based on what you're asked for the truth table for. And then lastly, your last case is where your P statement is false and your Q statement is false. So each line of your truth table is going to represent a case where your P is this value, your Q is this value, what happens at the end of the day. But now, you need more than just one column generally. And so you not only are going to look at how many component statements you are, because that's going to tell you how many rows you're going to have. You always have 2 to the n, where n is the number of component statements. You have 2 to the n rows. So here we have 2 component statements, a P and a Q. So we have 2 to the 2 rows, which is 4 rows. When you have 3 component statements, like a PQR, that will be 2 cubed rows, or 8 rows. So you look at how many component statements you have. Then you break down your end goal. So it looks like in Alex, they just give you the end goal, right? Here's my end goal, not Q implies P. Well, I need every single piece of this before I can get to not Q implies P. Now, in this case, the only thing we're missing is a not Q. So what I'm going to do is I'm going to make my own truth table here, because when you do this in the homework system, you just enter your answer. You don't enter necessarily all of your rows and all of your columns. You just enter the answer that they're looking for. So I'm going to make my P and my Q. And then to build not Q implies P, I need a not Q. And then I can then do not Q implies P. So these are all the columns for my truth table. And since they gave me this initial setup right here, I'm going to make sure that I have that. So I have P is true, Q is true. P is true, Q is false. P is false, Q is true. And then P is false, Q is false. So now when I make this truth table, I don't go row by row, I go column by column, and that way I'm only using one rule at a time. So in this next column, I will highlight it light blue. I don't know why I have 3 blue highlighters here, but this light blue here. So in this column, I'm going to use one rule. The rule I'm going to use is the not rule. And I'm going to refer to the Q column. So let's just go back for 1 second here. The not rule changes the truth value. So in row 1, Q is true right here. So I want to do the opposite of true, which is false. In row 2, Q is false. So not Q will be true. In row 3, Q is true. So not Q will be false. And in row 4, Q is false. So not Q will be true. So you see how my eyes, I kind of made a dot where my eyes were looking. My eyes look over at the Q column, decide to apply the rule, and then I applied that rule and I put my outcome in the not Q column. Now I have to connect not Q with P using the if then or the implies arrow. So not Q and P are like kind of over to the left, like they're not right next to each other. So what I like to do is I like to write them in the order that I'm using them, because remember, in an implies, order matters. So not Q was false, true, false, true. And then my P column here was true, true, false, false. So I put those down like small so my eyes don't have to go all over my page, because sometimes you're on like your 3rd or 4th column and you're referring back to your 1st and 2nd column. Like that's a lot of movement for your eyes. So instead of trying to make my eyes go back and forth, I just copy the columns into the corners of my into the column that I'm working in, so my eyes aren't moving. But now the other thing that I'm going to do is I'm going to write down the rule that I'm using. So this is the implies rule, and we're going to go back and we're going to look. The implies rule, all I need to remember is that true implies false equals false. Every other setup is going to be true. So what I'm going to do is I'm just going to write that rule down here. True implies false equals false. That's me reminding myself of what rule I'm going to use. And now I'm going to use that rule. So in row 1, I have false implies true. So false was first. So the outcome that equals is true. Next row. So I have true here, implies true here. So true implies true. That was okay, right? So true. In my next row, I have false implies false. So that was okay, right? So that's true. And then my last row, I have true implies false. And that was the bad one, right? That was that broken promise. They did what they were supposed to do and you didn't follow through. So that would be false. So now when I enter my answer, all I'm entering is this column here. And if you've made sure that you set them up in the same way that they were set up originally, then all you have to do is copy this column into your answer. So that was true, 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 false, true, 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 false. So To conclude, first you look at how many component statements you have to decide how many rows you're going to need. Then you look at your end goal, right? What do you want the truth table for? That's going to be like a crazy compound statement. So you're going to go and you're going to say, okay, what do I need to build this statement? And you're going to build it piece by piece. And if you don't want your eyes wandering around your page, you can write the 2 columns that you're using. Each step normally just uses 2 columns. So when I say break it down, you're like breaking it down into just 2 pieces and using 1 rule at a time instead of trying to do a bunch of rules at the same time.